Let's continue in section 3.5. We already talked about the function 1 over x, and now we want to look at 1 over x squared. We're going to make a table and a graph, and we're going to find some asymptotes. And you might want to stop the video now and fill in the table and make the graph for yourself to see how you do. Okay, so if we plug in -4 for x, -4 squares to 16, so we have 1 over 16, and then 1 over 4, and then 1 over 1, which is just 1. -1/2 squared is positive 1/4, and then 1 divided by 1/4 is 4, and then similarly we'll get 16 if the input is -1/4. When the input is 0, the output is undefined. 0 is not in the domain of the function because we can't divide by 0. If you put 1/4 into the function, you get 16, and then 4, and then 1, and then 1/4, and then 1/16. And we can go ahead and plot those points. -4 1/16 is really close to the x-axis, so it's a little bit hard to draw realistically, but that should be good enough. And then -2 1/4, that's pretty close to the x-axis too, isn't it? -1 1, -1/2 4. And then there's a jump over to the other side. There's a discontinuity at x equals 0. We jump over to the other side and we plot the point at 1/4 16. Actually, that one won't fit, but 1/2 4 will fit. And then 1 1, and then 2 1/4, and then 4 1/16. And then we can connect these up with a smooth curve. There are two sections to the graph, just like there were for the graph of 1 over x. The reason is because of the discontinuity at x equals 0. Notice at the left end of the graph and also at the right end of the graph levels out to 0. As x approaches plus or minus infinity out at the far right or the far left of the graph, y approaches 0. And that's exactly the criterion for a horizontal asymptote. So this graph, just like the last one, has a horizontal asymptote at y equals 0. The asymptote is the horizontal line that the graph approaches. And so y equals 0 is the equation of that horizontal line. Look in the middle of the graph. The y values shoot up to positive infinity when x gets very close to 0. That's exactly the condition for a vertical asymptote. As x approaches 0 on either the right side or the left side, y approaches infinity. And so that gives us a vertical asymptote at x equals 0. Again, the asymptote is a line that the graph is approaching, that the graph is getting closer to. And so when we write x equals 0, we're writing the equation of a vertical line. Okay, let's go ahead and run through a couple other features of this function. The domain. The domain is all possible x values. We can put any number in for x except for 0. So the domain is all real numbers except 0. And we like to write that in interval notation, so there it is. The range is only the positive numbers. because the numerator is positive 1. The denominator is also positive because it's squared. So it doesn't matter if the input is negative or positive. When we square that, we get a positive result. So the range is positive real numbers from 0 to infinity. There's no x-intercept. And there's no y-intercept. And there is a discontinuity. At x equals 0. Okay. How does that look? Before we go on to example 1, there are a couple of things that I want to say. So, first of all, I would like to remind you, you should be able to graph y equals 1 over x or y equals 1 over x squared from memory without making a table and without using graph paper. Just a rough sketch of the graph is all we need. The basic shape of the graph is all we need. And so there's 1 over x, and 1 over x squared is almost identical except now the graph is above the x-axis on both sides. Okay, so know these basic graphs. And then the other thing that I wanted to remind you about before we go to the transformations is I wanted to talk about basic functions. And that was a big theme in chapter 2 and now in chapter 3 as well. And so let's go back and let's write y equals x and y equals the absolute value of x. Y equals x squared and y equals the square root of x. Y equals x cubed and y equals the cube root of x. Those are the 6 basic functions we learned in section 2. I believe it was section 2.6. And so now we have 2 more to add to this list. We have y equals 1 over x and y equals 1 over x squared. We're actually going to get a few more basic functions in chapter 4. So that's an important theme throughout the course. Okay. Well, let's look at example 1 now. Let's use transformations to graph each of the following functions. And so when we're doing this, remember this is a 3-part process. The first step is to identify the basic function. So we have 8 to choose from. Which one is in this problem? Well, hopefully you'll say y equals 1 over x is the basic function. And then we need to describe the transformations in words. There's just one transformation this time. It's to add 2 onto the basic function. What does that do? Since the plus 2 is outside the basic function, since the 1 over x happens first and then the plus 2 is afterward or outside, we say that that's a vertical change. It's a vertical shift up 2. Vertical shift up 2. And then the third step is to go ahead and sketch the graph. And so we'll start with the origin and the x and y axes, and we'll draw y equals 1 over x. And then we just need to shift the whole thing up 2 units. Well, how are we going to do that? You know what I'd like to do is I'd actually like to draw this again. I think the left side looks a little bit better than the right, so let me make this one a little smaller, a little more symmetric, make it match a little better. I think that looks better. Okay, if we want to shift the whole graph up too, remember there was a horizontal asymptote here at y equals 0. It has to get shifted up 2 units as well. So let's start with that. And normally when we draw a horizontal asymptote, we draw a dashed line to represent it. We didn't do that before because the horizontal asymptote was always on top of the x-axis. Now the asymptote has moved off of the axis, and now we need a dashed line to represent it. We should put a scale on the graph, label 1, 2, and then we just want to take the blue curve and shift it up. We want to make sure that the green curve does not intersect, that the new curve, the green one, does not intersect with the old one, but it's just shifted up. And so that should do it. That's f of x is equal to 1 over x plus 2. Okay, well, let's do one more example. So let's look at g of x is equal to negative 1 over x plus 3 squared. What's the basic function this time? I bet you said y equals 1 over x squared. And then there are 2 transformations this time. The first transformation is inside the basic function. We have to add 3 before we square that denominator. So that's inside, that's a horizontal change, and since we're adding, that's a shift. And so we should be shifting left 3. So the transformation, the first one is shift left 3. And then the second transformation is the minus sign out in front, which represents a vertical reflection. And specifically, we're reflecting over the x-axis. Okay, so we can go ahead and graph the basic function, 1 over x squared, and then we should even label it y equals 1 over x squared, and then we should shift the graph to the left 3 units. So 1, 2, 3. Yep. And can you guess what I'm going to draw first on the new graph? I'm going to draw the vertical asymptote. The vertical asymptote was at x equals 0. And now, since it got shifted 3 units to the left, it's at x equals negative 3. So there's a vertical asymptote at x equals negative 3. And we can go ahead and draw the new graph around that asymptote. And that is the graph of y equals 1 over x plus 3 quantity squared. And then the last thing to do is to reflect that graph over the x-axis. So now it points down near x equals negative 3. And so the new graph in red is our function g of x equals negative 1 over x plus 3 squared. So the first big objective in this section was to identify the two new basic functions. And the second big objective was to use transformations of those basic functions to sketch some graphs. We finished both of those now.